Today we are going to discuss about the minimum detectable signal. So what is the definition of a minimum detectable signal? Is if the echo signal has minimum power, detecting that signal by the radar is known as a minimum detectable signal, or the weakest signal the receiver can detect is called minimum detectable signal. Here we are taking the output signal of receiver. So we are considering A, B, C are the targets of the target signal received by the receiver. So here this ABC is a combination of signal plus noise. A and B are the validity detectors and C is the missed detection. We are assuming here, for to explain the minimum detectable signal, we are assuming that ABC are the targets. So here A, if I am setting the threshold level, detection is based on establishing a threshold level of the output of the receiver. If the receiver output exceeds the threshold level and the signal is assumed to be target is present, this is called the threshold detection. Let us consider the output of the radar receiver as a function of time, as shown in the above figure. So it might be represent one sweep of video output display on the A-scope. Here we are taking the three conditions. One is the if a large signal is present such as A, and if a minimum signal it is present as like a C. If it is greater than the surrounding noise peak and can be recognized on the base of its amplitude, on the basics of its amplitude. Thus, the threshold level were set sufficient high, but the envelope would not generally exceed the threshold if noise alone is present, but would exceed it if a strong signal present. So suppose if the signal is very small, however it would be more difficult to recognize its presence. So the threshold level must be low if weak signal also to be detected, but it can be so low the noise cross the threshold and gives a false detection of the presence of target. A target is said to be detected if the envelope crosses the threshold. If the signal is large, such as A, it is difficult to decide that a target is present. If considered two signals, B and C represents the target, B, combination of signal and noise exceeds the threshold, and C, combination of signal noise not exceed the threshold. Thus, the presence of noise will sometimes enhance the detection of the weak signal, but it may also cause the loss of a signal, which would be otherwise detected. So, weak signals such as C would not be lost if the threshold level were lower, but too low of the threshold increase the noise alone will raise the threshold, and taken a real signal such as occurrence is called a false alarm. If the threshold is set too low, false targets indicates are obtained, but if it is too high, the targets might miss. So the selection of a proper threshold level is comprising that depends upon the probability of missing and probability of false alarm. Ante what it concludes is if you choose the threshold level properly, we cannot miss the target. So if you are choosing the minimum threshold level, we have to calculate the probability of missing and probability of false alarm. By that we can set the threshold levels of the receiver. Threshold decision has to be taken. So now what we are going to do, we are modifying the radar equation in terms of signal to noise ratio. So noise is unwanted electromagnetic energy which interferes with the ability of the receiver to detect the wanted signal. It may originate within the receiver itself, or it may enter via the receiver antenna along with the desired signal. So available threshold noise power is equals to K into T into Bn. So where is the K is the Boltzmann constant, Bn is the receiver bandwidth, and T is the temperature in degrees Kelvin, and N0 is the noise output from the receiver. So now what we are going to do is we are modifying the radar equation. In that we are introducing the noise also. So to find the relation between the noise and the signal, we are to estimate the noise figure. So noise figure also represent as signal to noise ratio by signal to noise ratio ratio output. So from above, the input signal may be expressed as Si is equals to K into T0 into Bn into Fn into S0 by N0. If the minimum detectable signal S minimum is the value of Si corresponding to the minimum ratio of the output of IF signal to noise ratio are necessary for detection, then S minimum is equals to K into T0 into B0 into B0 of S0 by N0. So substituting the above expression in the radar range equation, we are going to get PTGAE sigma by 4 pi sigma square into K into T0 Bn into Fn, that is bandwidth into signal to noise ratio minimum. So this we are going to modify the radar range equation in terms of noise. Radar range equation in terms of noise. Thank you.